So part A asks us to determine the null and the alternative hypothesis. So in this case, P1 will stand for people who married outside their race in 2008, while P2 stands for people who married outside their race in 1980. So we're trying to determine whether the difference in proportion has increased. So if there's more people compared to 1980 who marry outside their race. Now these two are given right here. These are given and this is given. So we can determine the number of successes, which we'll need for later calculation, and the number of failures, and they're all greater than 5. So we can proceed with the problem. This is a GMP table for the problem. Now we need to calculate the value of the test statistic and the p-value. We will be using this formula right here. I started by calculating the standard deviation right here. This is the formula for it. You can either use this one or this one. In either case, you will need this p, which is calculated by the total number of successes divided by the total people in the samples, in the two samples. So here's my calculation. It gives us 0.108, which we can use for the standard deviation, which will give us 0.04. And here's my calculation. So once we have 0.04, we can plug it into the denominator for the z. And then we calculate the numerator right here. And for z, it will be 1.95. Now in part C, they ask us to draw a conclusion based on a 5% level of significance. On a 5% level of significance, the z is 1.645. Our z is greater than that. That means that it lies inside the rejection regions. So we are rejecting the null hypothesis. So it means that the 5% level of significance, there is enough evidence to support the claim that the proportion of people who marry outside the race has increased since 1980, which is our alternative. Now, this is the problem done with JMP. JMP puts people in 1980 minus people in 2008. So it's the opposite of how it's done in my problem. So all we have to do really is multiply everything by -1, right? So the null hypothesis, we just have to flip that. In my case, because it was P1 minus P2 and they're doing P2 minus P1, in my case was less or equal, but we have to look at the greater or equal, which is right here, which is 0.0214, which is less than 0.05, right? This is 2.1%, which is less than 5%, so we are rejecting the null hypothesis. And for the confidence interval, we just have to multiply by -1, and it will give us this amount. Thank you.